Log on, tune in, find out. Another good idea from Cambridge.
School of Business at the University of Minnesota, and he'll be speaking on assessing the efficiencies of optimal discrete choice experiments in the presence of respondent fatigue.
Sorry, it's a pretty long title. First of all, thanks to Steve for inviting me to speak here, and thanks to all the organizers for inviting me to be here. This is such a wonderful chance for doing research, and really appreciate that. This is a joint work with several co-authors, we now it's kind of relatively easy to construct optimal discrete choice designs thanks to, for instance, software like JUMP. And one of the things we are, well, I should say the main thing we were considering here was what about fatigue? And fatigue could be a big factor. And one of the things, let me start with an example. And Rob, he works for, I should say he is the founder and the managing director of international company that specializes in using discrete choice experiments. And in one of the applications, when originally there were 12 choice sets and 4 profiles per choice set, and then there were like 6 attributes. The response rate was only 5%, and then, well, I guess you couldn't obtain much useful information from that. And then he cut the number of choice sets from 12 to 6, and then he also cut the number of attributes from 6 to 4, and then the response rate was like over 90%. So obviously fatigue had a lot to do with that. This is a pretty long abstract. It's kind of interesting. I debated on whether or not I should keep this last night. I was in Miami just last month, and I gave a talk amongst some other speakers on how to give good talks. And one of the first things we said was don't put too much on one slide. I realized I'm violating the most important principle we were talking about. Nonetheless, I realized that if later on you want to get the copy of the slide, copy of the presentation, sometimes it helps to have an abstract in it. So anyway, just didn't mean to make you bored by looking at this. Here's the outline of my talk. First of all, I'm going to talk about several discrete choice experiments, some applications. Then we're going to evaluate the efficiencies of the optimal, call it DCE, discrete choice experiments, with the factor of the fatigue by the respondent. We're going to see how much, we're going to quantify the loss of efficiency caused by fatigue. And then we're going to talk about some trade-offs between the choice sets, I should say the number of choice sets, number of profiles per choice set, and number of surveys. And of course, finally, we're going to talk about future research and some practical implications. This shows some important ideas about why the choice experiments have been widely used and what kind of information we can get from there. We see some big names like McFadden, for instance. I'm going to go through this very quickly, but I didn't want to read the slide, but I'd like to mention one story about what happened just 2 weeks ago. I was in China teaching an executive MBA basic statistics class, and I guess that was the least group I would expect getting, I should say, getting questions on choice experiments. I didn't even know that the choice experiments have been widely used in China. And then during one class break, I had a, by the way, those students were more like a higher level executives. So that was why I didn't expect them to know a lot about choice experiments. But then during one class break, I had, I was asked about, I was teaching Six Sigma and so forth, and more traditional thing. And then there's this student who came to me and said, "Do you happen to know anything about choice experiment?" I was like, "Wow, you want to go to Cambridge? I'm going to give a talk on that." Of course, I was joking, but he said, "We use this all the time." And it turned out that in China, there have been already quite a few applications on choice experiments. I guess it's just not many statisticians in China are doing research on that. So I guess the bottom line here is there have been a lot of DCE applications in industries, not just in marketing. And the guy I talked about, the student who talked to me, I knew his area is more on the manufacturing area, so not exactly marketing area. Anyway, so there are many applications of DCE, and I'm going to go through a real case study very quickly. And there was this fast food DCE design. There were 5 attributes, and we can see there are some attributes, for instance, have 2 levels, and some of them have 4 levels. And this DCE study was conducted by one of the co-authors, Rob. Yeah, another slide that violated the principle of not showing too much. Nonetheless, that was the real screenshot, and this study was conducted on the internet, and there's another kind of screenshot which showed what kind of questions they asked. I want us to focus on the next slide. Look at the fatigue effect. And when there were 20 screens, the response rate was only 47%. It goes to about 70% when we reduced the number of screens from 20 to 8. Actually, the finish rate or response rate is just one of the consequences caused by fatigue. Another thing which could happen, actually which happened quite often, is when you have too many choice sets, the respondents get, there was fatigue, and the respondents would not answer those questions as carefully as they should or as they have done at the beginning. So that was actually one of the main motivations for our work, which was to see how we can quantify the impact of fatigue. In just a few minutes, I'm going to show you the model, and we will focus on the variance part. Okay, a couple of quick notations here, and of course these are the important things: number of choice sets per survey, and number of profiles and attributes. Those are the kind of standard notations. And well, this is a pretty kind of standard model, and the multinomial, just in case you're not familiar with the terminology, is multinomial logit model. And also, I realize sometimes it helps when you are not the first speaker. Some of the formulas are probably shown by the previous speakers, so you could save some time, I guess. Anyway, this is the same kind of formula that we saw in the previous talk, and okay, this is one way of looking at the fatigue. In the previous model, we assumed that the variance there is constant variance, and that that obviously that is not true if we consider fatigue. For instance, let's say we've got several choice sets when the respondents work on the first choice set. The standard deviation could be smaller than than the case when they work on the later choice sets. Again, that's because of the fatigue. And so what I'm trying to emphasize here is, people get tired, so it may not be reasonable to assume that there is the equivariance assumption. And of course, we are not the first group of people who consider this. There was already this heteroscedastic multinomial logit model in which there's a lambda, which we could assume, lambda here is assumed to be proportional to the inverse of the standard deviation. And there's also this fancy name. Well, I thought it was pretty fancy when I first looked at that. It's called cumulative cognitive burden. And I could be wrong. I don't think it's the statisticians who first used this kind of fancy word. They were probably marketing people. I could be wrong. I know there are experts in the audience. Could correct me if I'm wrong. Anyway, so there have been there have been some papers on that. And for instance, one way to I'm going to come back to this in just a minute, but how people get fatigued because of several things, and one of the things is if there are too many choice sets, then obviously people would get more fatigue, and also how about the complexity of choices, and we're going to quantify this by looking at the total number of attribute levels people have to look at when they make choices. So again, all these papers were relevant, I should say very much relevant, and that was the message I tried to deliver earlier in my talk, and we kind of summarized it over here. So when the CCB, cumulative cognitive burden, increases, we would observe the dropout of respondents, and they would. It's also likely that the respondents would answer those questions without very, very careful discrimination. I guess one of the main consequences is, we'd see the variance of epsilon increases as when people work on later choice sets. This is a sort of a major assumption we make. So we try to quantify the CCB by linking it with just to refresh your memory, C is the number of choice sets the respondent has already evaluated by that time, and then LA are the attribute levels. P is the number of profiles per choice set. So we are assuming that CCB is related to these factors by a coefficient of W. And here's the assumption we make that links directly, that links W directly to lambda. Earlier in my talk, I showed the model, taking into account of lambda. So I guess then the next question is how can we determine W? It turned out that there were studies that kind of estimated lambda in the literature. So we took advantage of that, and I didn't show all the details here, but I believe it was a paper by Bradley and Day, and I think in 80s or 90s on a transportation study, and they actually look at the lambda. On the next page, I'm going to show you a slide of the scattergram. Anyway, so this is what we talked about. We found that we defined something called standard deviation inflation factor, and we assume that we will observe the inflation for later choice sets. And in that study I just mentioned, we calculated the standard deviation inflation factor to be 2.64, for which W is approximately equal to 0.0037. And using that as a benchmark, we also consider two cases. One is called mild fatigue, the other is called severe fatigue. And basically, in the mild fatigue case, the standard deviation of the model when the respondent works on the last choice set becomes twice as large as the standard deviation for the first one. And for the severe fatigue case, the standard deviation associated with the model evaluating the last choice set becomes, is 4 times as large as the first standard deviation. There's that was the data I talked about earlier on that transportation data. So in the paper they showed all the lambdas associated with the choice set. Okay, wow, I should speed up a little bit. Here are the important research questions. And first of all, we want to evaluate the loss of efficiency resulting from the fatigue effect. And then we want to talk about the possible trade-offs. There are some equations here, information matrices, and we also define the relative efficiency of two designs. Here are the assumptions. Use the kind of prior distributions defined here, and then we look at the expected efficiencies, we're going to see some results in just a few seconds. So we basically constructed a series of d-optimal designs using JUMP, keep in mind that when we do that, we don't consider the fatigue effect. So we just want to see, how much efficiency loss we'd observe, and you might find this interesting. Again, I apologize for having a small kind of a graph here. It's a little bit hard to read all the details, but we have the paper ready. So if you are interested, you can send me an email. This is directly from our paper. One of the graphs we showed in our paper. Of course, in the paper we always want to highlight the most extreme case that would be in favor of our results. So I'd like to get your attention on this one. So look at this. And by the way, again, I know you cannot see all the details, but we consider several cases with respect to different number of attributes and different number of attribute levels. And in this case, there are 6 attributes. So naturally, the fatigue is more severe. And we also look at the number of choice sets. For instance, if the number of choice sets is 16, the relative efficiency for the severe fatigue case is only, I think it's about 26%. And I guess from the design theory, that means you really need 4 times as large, 4 times as much as your runs if you want to achieve the same kind of accuracy you thought you'll get. So that was that was just one sort of simulation study that in which we try to quantify the efficiency loss. Now let me turn to the next research question, which is about the trade-off between choice sets and the profiles. I guess one of the main advantages of having a practitioner like Rob on the research team is, he would get to tell you what are the real interesting questions a practitioner wanted to answer. And one of the things we considered here was, assuming that, if we take into account the fatigue factor, assuming that a respondent can only evaluate this number of profiles in total, how should we allocate those profiles to choice sets? For instance, if in this case, keep in mind that choice sets, C is for the number of choice sets, P is for the number of profiles per choice set. So what we are doing here is to compare 3 cases. In the first case, each respondent would be shown 12 choice sets with 2 profiles per choice set. So it's 12 times 2. That's 24 profiles in total a respondent has to evaluate. In the second case is, we've got 8 choice sets and 3 profiles per choice set. And finally, 6 choice sets and 4 profiles per choice set. Again, we did some simulations. We considered several scenarios, and you can see that we consider different different attribute levels, and the message is kind of consistent in the sense that in all these 4 scenarios with different number of with different number of attribute levels, we can see that 12. This is the best. By the way, we showed the relative efficiency compared to the best case. In all four scenarios, the best case is to have 12 choice sets and 2 profiles per choice set. I should also mention that we did this. This graph is for the case without fatigue, because this is a more general question. Should we, if we have the same number of profiles, I should say total number of profiles to be evaluated by the respondent, how do we allocate them? We didn't show I didn't show the graph for the case with fatigue, but I could tell you that the results for designs with fatigue are very consistent with this one. What does the what do the results imply? I guess we this is a bit dramatic, the way to say it, but I have to admit that I copied some slides from one of the co-authors, Chris Naxheim. I noticed. Anyway, the bottom line here is, we should always use 2 profiles per choice set. I see that I've only got 1 minute. I think I'm on track. The next question we want to answer is how many for real practical case, how many surveys should we provide? I guess a common practice is just to have 1 survey and then you send it out to different respondents. Would that be the would there be a better approach? For instance, if we were to let me talk about a simplified scenario. Let's say if we are going to send out 5,000 surveys, should we provide 1 survey to 5,000 respondents, or 2 surveys each for 2,500 respondents? I'm going to skip some details, but I'm going to get your attention to the result page. Our conclusion at least from our simulation, was, we should try, we feel, sorry about that. I think it says better over here. I think that's the most extreme case. I mean, you should just send, if you take into account fatigue, you should just send one profile, one choice set to one respondent. So you would define different number of you would define different surveys. And here are the conclusions. Actually, that was the last one I meant to say. The first one was obviously fatigue leads to choice inconsistency, and again, we try to quantify the loss of efficiency. And also, we found that with or without fatigue, we should probably stick with the binary choices, which means we should put just 2 profiles per choice set. I realize I skipped the future research part, but that should be fine. And again, if you are interested in the talk, I'd be more than happy to send you the paper and the slides of my talk. Am I doing okay, Brett? Okay, that's all for my talk.
Our speaker's strategy was to avoid questions by using the entire time.
Brett is too smart, so that was my intention.
Any questions?
Did my strategy work, or?
You dazzled them with brilliance.
It's not a question, but as an observation of somebody who's completed these things, I approve of your conclusions.
I'm sorry, you...
I've received them, and when you got 4 profiles and you're on about number 10, you just think, why did I ever start this?
Oh, okay. Thank you.
Okay, let's thank the speaker again.